In this video, you're going to watch how I use the measurement tools and the graphing tools in Pivot Interactive to determine the speed of something. In this case, it's going to be the speed of a fireworks mortar that's ejected out of a cannon. Pretty cool. So here is the video, and you're going to be doing something similar for another object down below. And then you're going to need these tools to do your bowling ball challenge lab, and there's going to be some other things we're going to be doing later in the trimester. Anyway, so here's the video player, and it's got the video controls down here, just like you might think. There's play, and there it goes pretty fast, and you can, like you might expect, you can start and stop. And what's cool is you can go frame by frame. So well, let's get it back here, and you can also make, move the video around using the slider. And we can go frame by frame, forward and backwards, okay? But then we can also reset the whole thing. So this is what I want to know the speed of this projectile as it goes, boom, out of the projectile. And it is shot upward, but we're seeing it sideways. So, all right. So that's the video player itself. Pretty simple. Now, what are the measurement tools? So to get motion information, we really only need two tools, and that's what we have. We have basically a ruler, and we have a stopwatch. And so watch me use these tools to create a position versus time graph for this motion. Okay, so where am I? All right, so let's get started. So let's pick a point in the video where we see the thing just being ejected. So I'm just going to pick that point there. Okay. Now, what do we have here? This is our data table. I've already preset the times, which will look a little weird, but we're going to basically take 6 data points, and we're going to record the position using the ruler, and then there's going to be a graph of that position versus time data, and then we're going to get the slope of that to get the velocity. So let's get started. Okay, so let's get our stopwatch, and you reset it to 0, or set it to 0 by clicking on, I don't know what L stands for. But anyway, we click on it, read 0. And we get out our ruler, and we notice that it's in centimeters. And I'm going to put the leading edge, the 0 mark on the leading edge of the projectile. And we're ready to start collecting data, which goes pretty fast because I already have my first data point. At 0 seconds, it has a position of 0, well, not P, 0 centimeters from the origin. Now we're going to advance 1 frame. And you can see that the time is 0.001. So this is happening very, very fast. So this is like a thousandth of a second later. And we're going to just record that position. And I'm going to say that it's at a position of 6 centimeters. And then we're going to go through and do a couple more, and then I'll probably pause the video. Okay, now we're at 0.0021 seconds, and I'm looking at the leading edge, and I'm going to say that it's at 12 centimeters. Oh, we don't need to pause it. We're just going to go fast. I go forward again. I'm going to say it's at a position of, it's a little fuzzy. I'm going to say 18. Yeah, 18 centimeters. We're almost done. So let's just finish it up. And then the next frame, I'm going to say it's at 24 centimeters. I'm just looking at that leading edge there. I go one more frame, and it gets a little fuzzy there, but so 29.5. Maybe it's 30. Maybe it's 29. Okay, because then we're done. We're now done collecting the data. And we go down to the graph, and you'll see the same thing in your challenge lab. And for this practice, well, what I want to do, I want to get rid of that line, though. That's not supposed to be there. So you won't see that line. This is what you're going to see. You'll see the data points, and they do line up in a straight line, which we've seen as constant motion on position versus time graph. And you're going to click this little gear, and you're going to go down to curve fits, and you're going to click on the menu choice, and you're going to go to linear. You're going to click on that, and you're going to get, should be a straight line. You can see my data points don't line up perfectly, but it's pretty darn straight. And here's the key information. So if you look at this position, this is our position equals Now it has a, sorry, the cursor's going a little nuts here, a times t plus b. Well, the a is that velocity. That's our v times t, and it's 5.67 times 10 to the 3 centimeters per second. So that's 5,670 centimeters per second. That's 50-some meters per second. That's well over 100 miles an hour. So that thing's going pretty fast. That's what you're going to do in the next section. So you watched me do it. You can replay this video if you need to. But this is exactly what you're going to be doing in the next section, except it's going to be your turn.